Good morning. It's been a while since we've done something like this where I read a book as if I was an audiobook to you. Last time we did that, we were pretty deep into the Linux kernel. But since then, I haven't really done much of that. And I kind of want to do that again, especially since I have had an itch to read something lately. And so I have a physical copy of this book. Uh, so let's read this book here. Um, Probably going to be blurred, but it's called Deep Learning for Coders with Fast AI and PyTorch, and it's supposed to be like a practical approach to learning AI, not just LLMs, but AI in general. Uh, and it's written by Jeremy Howard, who's pretty well known in the community. He I've known his name from like a bunch of Kaggle competitions, and he has online courses available for you to actually learn AI in a very approachable way. I'm not going to say any more about that. Let's just begin. So I have this PDF here. Again, you might just want to search for that yourself. I'm not going to provide it. You should just go and buy the book. But yeah. So as always, we're going to try and read this thing word for word, but we don't need to read any of these testimonials. And if you don't like any of these videos, as in me reading to you, just you don't have to watch it. But I think some people like it because I end up making comments. It's like a reaction video. So anyway, this book is written in 2020, so it did happen before ChatGPT came out and everyone getting really super psyched about AI, at least with transformer models. So most likely this book is not going to go too deep into transformer models, even though that uh, when it was written, transformers had already been like researched and written about with all you need is attention. So yeah, it's not like it didn't exist yet. It's just that it wasn't huge yet. So most likely we should expect some discussion here. But basically, this is like a book that allows us to practice some deep learning concepts using PyTorch, but within the FastAI library. And that's a library that, oopsie. And that's a library that Jeremy Howard contributes to. So we're going to go down past the table of contents here. It looks like it's going to be a long book, well into probably 500 pages. Yep. So here we go. Preface. And okay, here we go. Deep learning is a powerful new technology, and we believe it should be applied across many disciplines. Domain experts are most likely to find new applications of it, and we need more people from all backgrounds to get involved and start using it. That's why Jeremy co-founded Fast.ai to make deep learning easier to use through free online courses and software. Sylvain is a research engineer at Hugging Face. Previously, he was a research scientist at FastAI and a former mathematics and computer science teacher in a program that prepares students for entry into France's elite universities. Together, we wrote this book in hope of putting deep learning into the hands of many people as possible. So, FastAI, apparently a website. So, fast.ai. Here we go. So, I think we'll most likely dive further into this website, but I do remember I visited this a few years ago, and there was a course, yeah, practical deep learning for coders. So this one is something that I had looked at for a bit. It's like a kind of like a survey of what deep learning really is. I believe it's still relevant to this day, even though like everyone's obsessed with transformer models. So good resource here. We'll come back to it. I'm pretty sure throughout the book, so let's not worry about that for now. Anyway, who this book is for. If you're a complete beginner to deep learning and machine learning, you are most welcome here. Our only expectation is that you already know how to code, preferably in Python. Okay, yeah, we know some Python. No experience, no problem. If you don't have any experience coding, that's okay too. The first 3 chapters have been explicitly written in a way that will allow executives, product managers, etc. to understand the most important things they'll need to know about deep learning. When you see bits of code in the text, try to look them over to get an intuitive sense of what they are doing. Okay. Let me just try to get my pen ready because I realize that the mouse is much harder to control. Okay, there we go. Okay. So we'll explain them line by line. The details of the syntax are not nearly as important as a high-level understanding of what's going on. Okay, even though we know how to code in Python, we're just going to go through the entire book anyway. If you're already a confident deep learning practitioner, you will find a lot here. In this book, we will be showing you how to achieve world-class results, including techniques from the latest research. As we will show, this doesn't require advanced mathematical training or years of study. It just requires a bit of common sense and tenacity. What you need to know. As we said before, the only prerequisite is that you know how to code. A year of experience is enough, preferably in Python, and that you have at least followed a high school math course. It doesn't matter if you remember little of it right now, we will brush up on it as needed. Khan Academy has great free resources online that can help. We are not saying that deep learning doesn't use math beyond high school level, but we will teach you or direct you to resources that would teach you the basics you need as we cover the subjects that require them. The book starts with the big picture and progressively digs beneath the surface, so you may need, from time to time, to put it aside and go learn some additional topic, a way of coding something or a bit of math. So in the beginning, I had trouble with the math part since I didn't really have a good math background. I had to go back a lot and try to learn a little bit more math to be able to at least understand some deep learning. I've read a couple chapters of this book already once before a few years ago. So but this time I'm determined to finish it. That is completely okay, and it's the way we intend the book to be read. Start browsing it and consult additional resources only as needed. Please note that Kindle or other e-reader users may need to double-click images to view the full-size versions. Oh, that's cool. Okay, so yeah, all the code examples in this book are available online in the form of Jupyter notebooks. I'm pretty sure that's in the fastai website. Anyway, I'm excited. Here's what we're going to learn. After reading this book, you will know the following. How to train models that achieve state-of-the-art results in computer vision, including image classification, classifying pet photos by breed, for example, and image localization and detection, such as finding the animals in an image. I'm really interested in stuff like this, like computer vision, since it's like kind of like the work that I do day to day. Natural language processing, NLP, including document classification, so movie review sentiment analysis, and language modeling. We also have tabular data, sales prediction with categorical data, continuous data, and mixed data, including time series. Collaborative filtering, recommendations, basically. Then we can turn our models into web applications. So basically create a service around our models and create some sort of application that we can use through the web to inference with our model. Why and how deep learning models work, and how to use that knowledge to improve the accuracy, speed, and reliability of your models. Then we'll also learn the latest deep learning techniques that really matter in practice. So that's important, practice. So the real world stuff. And then, this is exciting, how to read a deep learning research paper. We should probably do more of that. So we also learn how to implement deep learning algorithms from scratch and how to think about the ethical implications of your work. This is very important. I feel like this is not even talked about enough, especially in like YouTube, for example. We don't have enough videos on it, or at least exciting discussions on it, to help ensure that you're making the world a better place and that your work isn't misused or for harm. Sorry. See the table of contents for a complete list, but to give you a taste, here are some of the techniques covered. Don't worry if none of these words mean anything to you yet, you'll learn them all soon. So we're going to learn affine functions and nonlinearities, parameters and activations, random initialization and transfer learning, SGD, momentum, atom, and other optimizers, convolutions, batch normalization, dropout, data augmentation, weight decay, ResNet and DenseNet architectures, image classification and regression, embeddings, recurrent neural networks, RNNs, which is basically, I think, superseded by transformers, but still good to know anyway for background, segmentation, UNet, which is also like kind of like a backbone of stable diffusion, so image generation, and much more. Okay, so chapter questionnaires. If you look at the end of each chapter, you'll find a questionnaire. That's a great place to see what we cover in each chapter, since we hope by the end of each one, you'll be able to answer all the questions there. In fact, one of our viewers, thanks Fred, said he likes to read the questionnaire first before reading the chapter, so he knows what to look out for. Forward. So in a very short time, deep learning has become a widely useful technique, solving and automating problems in computer visions, robotics, healthcare, physics, biology, and beyond. One of the delightful things about deep learning is its relative simplicity. Okay, so powerful deep learning software has been making getting started fast and easy. In a few weeks, you can understand the basics and get comfortable with the techniques. This opens up a world of creativity. You start applying it to problems that you have data at hand, and you feel wonderful seeing a machine solving problems for you. However, you slowly feel yourself getting closer to a giant barrier. You built a deep learning model, but it doesn't work as well as you had hoped. This is when you enter the next stage, finding and reading state-of-the-art research on deep learning. However, there's a voluminous body of knowledge on deep learning. Yeah, it can be overwhelming. There's so much out there, with 3 decades of theory, techniques, and tooling behind it. As you read through some of this research, you realize that humans can explain simple things in really complicated ways. Scientists use words and mathematical notation in these papers that appear foreign, and no textbook or blog post seems to cover necessary background that you need in accessible ways. But we do have a secret weapon for this. We will now introduce Gemini and ChatGPT into the mix. So we don't understand anything, we can look to these two language models here and help us understand some of the concepts that are over our head. So that's different this time around as I'm reading this. Okay, so engineers and programmers assume you know how GPUs work and have knowledge about obscure tools. I think that's our advantage here. We know how GPUs work, and we do have some knowledge on obscure tools. So I think they probably just mean like Linux and software development things here. Anyway, this is when you wish you had a mentor or a friend that you could talk to. We'll have each other, so that's okay. Someone who was in your shoes before, who knows the tooling and the math, someone who could guide you through the best research, state-of-the-art techniques, and advanced engineering, and make it comically simple. I don't think that's what we're looking for. We just look to understand. I don't think it needs to be that simple, just as long as we get it. I was in your shoes a decade ago when I was breaking into the field of machine learning. For years, I struggled to understand papers that had a little bit of math in them. I had good mentors around me, which helped me greatly, but it took me many years to get comfortable with machine learning and deep learning. That motivated me to co-author PyTorch, a software framework to make deep learning accessible. Whoa, this is the creator of PyTorch talking. Okay, so Jeremy Howard and Sylvain Gugar were also in your shoes. They wanted to learn and apply deep learning without any previous formal training as ML scientists or engineers. Like me, Jeremy and Sylvain learned gradually over the years and eventually became experts and leaders. But unlike me, Jeremy and Sylvain selflessly put a huge amount of energy into making sure others don't have to take the painful path that they took. They built a great course called fastai that makes cutting-edge deep learning techniques accessible to people who know basic programming. It has graduated hundreds of thousands of eager learners who have become great practitioners. In this book, which is another tireless product, Jeremy and Sylvan have constructed a magical journey through deep learning. They use simple words and introduce every concept. They bring cutting-edge deep learning and state-of-the-art research to you, and yet make it very accessible. You are taken through the latest advances in computer vision, dive into natural language processing, and learn some foundational math in a 500-page, delightful ride. And the ride doesn't stop at fun as they take you through shipping your ideas to production. You can treat the Fast.ai community, thousands of practitioners online, as your extended family, where individuals like you are available to talk and ideate small and big solutions, whatever the problem may be. I am very glad you found this book, and I hope it inspires you to put deep learning to good use, regardless of the nature of the problem. Sumit Chintala, co-creator of PyTorch. Excellent. Part 1, Deep Learning in Practice. Okay. Chapter 1, Your Deep Learning Journey. Hello, and thank you for letting us join you on your deep learning journey, however far along that you may be. I should probably read that again. Hello, and thank you for letting us join you on your deep learning journey, however far along that you may be. In this chapter, we will tell you a little bit more about what to expect in this book, introduce the key concepts behind deep learning, and train our first models on different tasks. It doesn't matter if you don't come from a technical or mathematical background, though it's okay if you do too. We wrote this book to make deep learning accessible to as many people as possible. Deep learning is for everyone. A lot of people assume that you need all kinds of hard to find stuff to get great results with deep learning. But as you'll see in this book, those people are wrong. Table 1-1 right here lists a few things that you absolutely don't need for world-class deep learning. So what don't we need? We don't need lots of math. The truth is high school math is sufficient. I still think that's like kind of just a little over the top. Like it's not quite like true, but okay. Lots of data. We've seen record-breaking results with less than 50 items of data. Again, I think, for traditional maybe models, maybe if you run a lot of iterations. Lots of expensive computers. You can get what you need for state-of-the-art work for free, or even on your laptop, which I am on right now with just a 8GB GPU. You can get a lot done. Deep learning is a computer technique to extract and transform data with use cases ranging from human speech recognition to animal imagery classification. By using multiple layers of neural networks, each of these layers takes its inputs from previous layers and progressively refines them. The layers are trained by algorithms that minimize their errors and improve their accuracy. In this way, the network learns to perform a specific task. We will discuss training algorithms in detail in the next section. Deep learning has power, flexibility, and simplicity. That's why we believe it should be applied across many disciplines. These include the social and physical sciences, the arts, medicine, finance, scientific research, and many more. To give a personal example, despite having no background in medicine, Jeremy started Enlitic, a company that uses deep learning algorithms to diagnose illness and disease. Within months of starting the company, it was announced that its algorithm could identify malignant tumors more accurately than radiologists. Okay, I think I've heard about this before. Oh dear. Okay. Oh geez. Okay, you know what? Forget it. Okay. Here is a list of some of the thousands of tasks in different areas for which deep learning or methods heavily using deep learning is now the best in the world. Okay, different types of tasks for different types of deep learning methods. Here we go. Natural language processing, or NLP. So what are the applications? answering questions, speech recognition, summarizing documents, classifying documents, finding names, dates, etc. in documents, and searching for articles mentioning a concept. Huh, that sounds like LLMs. Computer vision, satellite and drone imagery interpretation, for example, disaster resilience, face recognition, image captioning, reading traffic signs, locating pedestrians and vehicles and autonomous vehicles. So your VLMs are probably trained like this too through computer vision techniques. Medicine, finding anomalies in radiology images, including CT, MRI, and X-ray images, counting features in pathology slides, measuring features in ultrasounds, and diagnosing diabetic retinopathy. Okay. Biology, folding proteins, classifying proteins, many genomics tasks such as tumor normal sequencing, and classifying clinically actionable genetic mutations, cell classification, analyzing protein to protein interactions. Image generation, colorizing images, increasing image resolution, removing noise from images, and converting images into art in the style of famous artists. So this is in the beginning of all this stable diffusion stuff, I think, at that moment. Recommendation systems, web search product recommendations, and homepage layout. This is very popular for things like your Amazon page or like your Netflix browse page. So the homepage is kind of determined by your content recommendations. Playing games, so chess, Go, most Atari video games, and many real-time strategy games. So this is what we're trying to do with our Game Boy AI. Robotics, handling objects that are challenging to locate, transparent, shiny, lacking texture, or hard to pick up. And then other applications, financial and logistical forecasting, text-to-speech, and much, much more. Okay. What is remarkable is that deep learning has such varied applications, yet nearly all of deep learning is based on a single innovative type of model, the neural network. But neural networks are not, in fact, completely new. In order to have a wider perspective on the field, it's worth starting with a bit of history. Okay, so the history of neural networks. Here we go. Neural networks, a brief history. In 1943, Warren McCulloch, a neurophysiologist, and Walter Pitts, a logician, teamed up to develop a mathematical model of an artificial neuron. In their paper, A Logical Calculus of Ideas Immanent in Nervous Activity, they declared the following. Because of the all or none character of nervous activity, neural events and the relations among them can be treated by means of propositional logic. It is found that the behavior of every net can be described in these terms. What does that mean? McCulloch and Pitts realized that a simplified model of a real neuron, okay, so that's what it's saying, like you can take a neuron and model it, and you could represent that neuron using simple addition and thresholding. So basic operations, as shown in figure 1.1. Pitts was self-taught and by age 12 had received an offer to study at Cambridge University with the great Bertrand Russell. He did not take up this invitation and indeed throughout his life did not accept any offers of advanced degrees or positions of authority. Most of his famous work was done while he was homeless. Despite his lack of an officially recognized position and increasing social isolation, his work with McCulloch was influential and was taken up by a psychologist named Frank Rosenblatt. Frank Rosenblatt. Okay, so they're saying that you can take a neuron and you can just represent that neuron with simple addition and thresholding. What does that mean? Well, I think Frank Rosenblatt is going to prove something. So here's your neuron. Okay, this is like a real neuron. Nucleus, dendrites, and here's your cell body, axon terminals. You can model that as basically some machine in here that is given input and just gives out output. I know. Yeah. But basically, You can connect these outputs to other inputs in this case. Okay, I know. It's obvious. So Rosenblatt further developed the artificial neuron to give it the ability to learn. Even more importantly, he worked on building the first device that could use these principles. So like the first deep learning model with, or actually, I should correct myself, the first neural network in this case. The Mark I perceptron is what it was called. In the design of an intelligent automation, Rosenblatt wrote about this work. We are now about to witness the birth of such a machine capable of perceiving, recognizing, and identifying its surroundings without any human training or control. The perceptron was built and was able to successfully recognize simple shapes. That's amazing. In what year? 1950s? 1943? Yeah, something like that. 1943. So 1940s, 1950s. Jeez. Okay. So we've been doing this for a while. An MIT professor named Marvin Minsky, who was a grade behind Rosenblatt at the same high school, along with Seymour Papert, wrote a book called Perceptrons by MIT Press about Rosenblatt's invention. They showed that a single layer of these devices was able to learn some simple. Whoa, 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 whoa. Let's read that in. They showed that a single layer, one layer of a bunch of perceptrons. Okay, so one layer. So let's just take the perceptrons again. Okay, one layer of these was unable to learn concepts. Okay, so that's what's going on in my head right now. Okay, so was unable to learn some simple but critical mathematical functions. Oh, so it couldn't learn XORs and ands and probably those types of things. Okay, so in the same book, they also showed that using multiple layers of these devices would allow these limitations to be addressed. Okay, cool. So, just to make ourselves grounded, this, let's say an XOR, did not work, right? So let me just get the colors going. Okay, there we go. Here we go. So that didn't work. But if we had, let's say, multiple of these, right? So we had multiple of these. Let's just do that. Then XOR. So things like XOR, sorry, are good. Okay. So one layer network versus multiple layers. And I'm guessing where we're going with this is deep neural network. So the more layers, they probably found that the more layers they had, the more complex problems that they were able to solve. Just guessing, predicting the future. Unfortunately, only the first of these insights was widely recognized. So only the single layer part was recognized by others as saying, hey, we have one layer of these perceptrons, they can't really learn anything. Okay, but they I guess completely missed the fact that, well, if you stack multiple layers of them like this, then it could learn something. So because of that, as a result, the global academic community nearly entirely gave up on neural networks for the next 2 decades because they missed this second part here. Okay. Perhaps the most pivotal work in neural networks in the last 50 years was the multi-volume parallel distributed processing, or PDP, by, oh, this is a book, huh? I'm just see. I'm looking for some books, so let's see. Control C. It's kind of old now, but okay. By David Rumelhart and James McClelland. and the PDB research group released in 1986 by MIT Press. Chapter 1 lays out a similar hope to that shown by Rosenblatt. So here's the excerpt here. So people are smarter than today's computers because the brain employs a basic computational architecture that is more suited to deal with a central aspect of the natural information processing tasks that people are so good at. We will introduce a computational framework for modeling cognitive processes that seem closer than other frameworks to the style of computation as it might be done by the brain. So goal is to model the human brain in code so that the hope is we could use this model to learn just like how we do. The premise that PDP is using here is that traditional computer programs work very differently from brains, and that might be why computer programs had been, at that point, so bad at doing things that brains find easy, such as recognizing objects and pictures. The authors claimed that the PDP approach was closer than other frameworks to how the brain works, and therefore it might be better to handle these kinds of tasks. In fact, the approach laid out in PDP is very similar to the approach used in today's neural networks. The book defined parallel distributed processing as requiring the following. Okay, first we need to set processing units, a state of activation, an output function for each unit, and a pattern of connectivity among units. Okay, so spoiler alert, that's a neural network. Okay, a propagation rule for propagating patterns of activities through the network of connectivities, an activation rule for combining the inputs impinging on a unit with the current state of that unit to produce an output for the unit. Okay, and a learning rule whereby patterns of connectivity are modified by experience. So I guess loss calculations. And an environment within which the system must operate. Your system, I guess, your operating system. So we will see in this book that modern neural networks handle each of these requirements. Here we go. In the 1980s, most models were built with a second layer of neurons, thus avoiding the problem that had been identified by Minsky and Papert. This was their pattern of connectivity among units to use the preceding framework. And indeed, the neural networks were widely used during the 80s and 90s for real practical projects. So they did eventually in the 80s find that stacking these layers did help learn. And so most of them were just two-layer neural networks in this case, as that's what it's implying. Anyway, however, again, a misunderstanding of the theoretical issues held back the field. In theory, adding just one extra layer of neurons was enough to allow any mathematical function to be approximated with these neural networks. But in practice, such networks were often too big and too slow to be useful. Remember, we were in the 80s and 90s here. We did not have that much computing power. Okay. So, although researchers showed 30 years ago that to get practical good performance, you would need to use even more layers of neurons, it is only in the last decade that this principle has been more widely appreciated and applied because faster, more compute available. Neural networks are now finally living up to their potential thanks to the use of more layers coupled with the capacity to do so because of improvements in computer hardware, increases in data availability, and algorithmic tweaks that allow neural networks to be trained faster and more easily. We now have what Rosenblatt promised, a machine capable of perceiving, recognizing, and identifying its surroundings without any human training or control. Oops. Get rid of that. Okay. So this is what you will learn. This is what you will learn how to build in this book. But first, since we are going to be spending a lot of time together, let's get to know each other a bit. Okay. Who we are. We are Sylvan and Jeremy, your guides on this journey. We hope that you will find us well suited for this position. I think so. I put my trust in you. Jeremy has been using and teaching machine learning for around 30 years. Yeah, I definitely trust you. He started using neural networks 25 years ago. During this time, he has led many companies and projects that have machine learning at their core, including the founding the first company to focus on deep learning and medicine, Analytic, and taking on the role of president and chief scientist at the world's largest machine learning community, Kaggle. He is the co-founder, along with Dr. Rachel Thomas, of FastAI, the organization that built this course this book is based on. Okay. From time to time, you will hear directly from us in the sidebars, like this one from Jeremy. Jeremy says, "Hi everybody, I'm Jeremy. You might be interested to know that I do not have any formal technical education. I completed a BA with a major in philosophy and didn't have great grades. I was much more interested in doing real projects and theoretical studies. So I worked full-time at a management consulting firm called McKinsey and Company throughout my university years. If you're somebody who would rather get their hands dirty building stuff than spend years learning abstract concepts, you will understand where I'm coming from. Look out for sidebars from me to find information most suited to people with a less mathematical or formal technical background. That is for people like Jeremy or maybe myself. I don't consider myself very good at math. So, yeah. Sylvan, on the other hand, knows a lot about formal technical education. He has written 10 math textbooks covering the entire advanced French math curriculum. Wow. Okay. Unlike Jeremy, I have not spent many years coding and applying machine learning algorithms. Rather, I recently came to the machine learning world by watching Jeremy's FastAI course videos. So if you are somebody who has not opened a terminal and written commands at the command line, you will understand where I am coming from. Look out for sidebars from me to find information most suited to people with a more mathematical or formal technical background, but less real world coding experience. That is, people like me. And debatable, I guess, you can always learn how to get better at coding, so people like myself too. Okay. So the FastAI course has been studied by hundreds of thousands of students from all walks of life, from all parts of the world. Sylvan stood out as the most impressive student of the course that Jeremy had ever seen, which led him to join FastAI and then becoming the co-author along with Jeremy of the FastAI software library. All this means that between us, you have the best of both worlds. The people who know more about the software than anybody else because they wrote it, and an expert. Oh, so by the way, they're referring to FastAI, not PyTorch. Okay, so we're doing two things. We're gonna be using FastAI on top of PyTorch. Jeremy and Sylvan are like the guys who did FastAI. And we heard from I think Somit Chintala, the one who wrote PyTorch early on in the forward. Okay, so an expert on math and an expert on coding and machine learning, and also people who understand both what it feels like to be a relative outsider in math and a relative outsider in coding and machine learning. Anybody who has watched sports knows that if you have a two-person commentary team, you also need a third person to do special comments. Yes, our special commentator is Alexis Gallagher. Alexis has a very diverse background. He has been a researcher in mathematical biology, a screenplay writer, oh wow, an improv performer, and a McKinsey consultant, just like Jeremy, a Swift coder and a CTO. Wow. Alexis says, "I've decided it's time for me to learn about this AI stuff." Oh, you're not alone. After all, I've tried pretty much everything else, but I don't have a background in building machine learning models. Still, how hard can it be? I'm going to be learning throughout this book, just like you are. Look out for my sidebars for learning tips that I found helpful on my journey, and hopefully you will find helpful too. Okay, how to learn deep learning. Harvard professor David Perkins, who wrote Making Learning Whole, Josie Bass, has much to say about teaching. The basic idea is to teach the whole game. That means if you're teaching baseball, that means that if you're teaching baseball, you first take people to a baseball game or get them to play it. You don't teach them how to wind intertwine to make a baseball from scratch, the physics of a parabola, or the coefficient of friction of a ball on a bat. Paul Lockhart, a Columbia math PhD, former Brown professor and K-12 math teacher, imagines in the influential essay A Mathematician's Lament a nightmare world where music and art are taught the way math is taught. Children are not allowed to listen to or play music until they have spent over a decade mastering musical notation and theory, spending classes transposing sheet music into a different key. And in art class, students study colors and applicators but aren't allowed to actually paint until college. Sound absurd? This is how math is taught. We require students to spend years doing rote memorization and learning dry, disconnected fundamentals that we claim will pay off later, long after most of them quit the subject. Unfortunately, this is where many teaching resources on deep learning begin, asking learners to follow along with the definition of the Hessian and theorems for the Taylor approximation of your loss functions, without ever giving examples of actual working code. We're not knocking calculus, we love calculus, and Sylvan has even taught it at the college level, but we don't think it's the best place to start when learning deep learning. In deep learning, it really helps if you have the motivation to fix your model to get it to do better. That's when you start learning the relevant theory, but you need to have the model in the first place. We teach almost everything through real examples. As we build out those examples, we go deeper and deeper, and we'll show you how to make your projects better and better. This means that you'll be gradually learning all the theoretical foundations you need, in context, in such a way that you'll see why it matters and how it works. So here's our commitment to you. Throughout this book, we follow these principles, teaching the whole game. We'll start off by showing you how to use a complete working usable state-of-the-art deep learning network to solve real-world problems using simple expressive tools. And then we'll gradually dig deeper and deeper into understanding how those tools are made, and how the tools that make those tools are made, and so on. Always teaching through examples. We'll ensure that there's a context and a purpose that you can understand intuitively, rather than starting with algebraic symbol manipulation. Simplifying as much as possible. We spent years building tools and teaching methods that make previously complex topics simple. Removing barriers. Deep learning has until now been an exclusive game. We're breaking it open and ensuring that everyone can play. The hardest part of deep learning is artisanal. How do you know if you've got enough data, whether it is in the right format, if your model is training properly, and if it's not, what should you do about it? That's why we believe in learning by doing. As with basic data science skills, with deep learning you get better only through practical experience. Trying to spend too much time on the theory can be counterproductive. So you just gotta do it and not overthink it. The key is to just code and try to solve problems. The theory can come later, when you have context and motivation. There will be times when the journey feels hard, times when you feel stuck. Don't give up. Rewind through the book to find the last bit where you definitely weren't stuck, and then read slowly through from there to find the first thing that isn't clear. Then try some code experiments yourself and Google around for more tutorials on whatever the issue you're stuck with is, or consult an LLM. They're generally pretty good at helping you get unstuck. It's not like they're going to answer the question for you, but they can kind of get your brain going. Or you can have it formulate a search query. So often you'll find a different angle on the material that might help it to click. Also, it's expected and normal to not understand everything, especially the code on first reading. Trying to understand a material serially before proceeding can sometimes be hard. Sometimes things click into place after you get more context from parts down the road, from having a bigger picture. So if you do get stuck on a section, try moving on anyway and make a note to come back to it later. Remember, you don't need any particular academic background to succeed at deep learning. Many important breakthroughs are made in research and industry by folks without a PhD, such as the paper Unsupervised Representation Learning in Deep Convolutional Generative Adversarial Networks, one of the most influential papers of the last decade with over 5,000 citations, which was written by Alec Radford when he was an undergraduate. Even at Tesla, where they're trying to solve the extremely tough challenge of making a self-driving car, CEO Elon Musk says, a PhD is definitely not required. All that matters is a deep understanding of AI and ability to implement neural networks in a way that is actually useful. The latter point is what is truly hard. Don't care if you even graduated high school. So what you will need to do to succeed, however, is to apply what you learned in this book to a personal project and always persevere. So we're going to try and always persevere in this book here. Your projects and your mindset. Whether you're excited to identify if plants are diseased from pictures of their leaves, auto-generate knitting patterns, diagnose TB from x-rays, or determine when a raccoon is using your cat door, we will get you using deep learning on your own problems via pre-trained models from others as quickly as possible, and then we'll progressively drill into more details. You'll learn how to use deep learning to solve your own problems at state-of-the-art accuracy within the first 30 minutes of the next chapter. And feel free to skip straight there now if you're dying to get coding right away. There's a pernicious myth out there that you need to have computing resources and data sets the size of those at Google to be able to do deep learning. But it's not true. That's true. You don't need really, really big data to get started, and you can do everything through a laptop. What sorts of tasks make for good test cases? You could train your model to distinguish between Picasso and Monet paintings, or to pick out pictures of your daughter instead of pictures of your son. It helps to focus on your hobbies and passions. Setting yourself 4 or 5 little projects rather than striving to solve a big grand problem tends to work better when you're getting started. Since it is easy to get stuck, trying to be too ambitious too early can often backfire. Then, once you've got the basics mastered, aim to complete something you're really proud of. So Jeremy says, deep learning can be to set work on almost... let me read that again. Deep learning can be set to work on almost any problem. For instance, my first startup was a company called Fastmail, which provided enhanced email services when it launched in 1999 and still does to this day. In 2002, I set it up to use a primitive form of deep learning, single-layer neural networks to help categorize emails and stop customers from receiving spam. Common character traits in people who do well at deep learning include playfulness and curiosity. The late physicist Richard Feynman is an example of someone we'd expect to be great at deep learning. His development of an understanding of the movement of subatomic particles came from his amusement at how plates wobble when they spin in the air. That's true. The more curious you are about things, the easier it is to learn new things. So let's focus on what you will learn starting with the software. Okay, so this is the software stack. The software, PyTorch, fastai, and Jupyter, and why it doesn't matter. Okay, it doesn't matter. I think it's going to be the concepts that matter, not really the software itself. So we've completed hundreds of machine learning projects using dozens of packages and many programming languages. At FastAI, we have written courses using most of the main deep learning and machine learning packages used today. After PyTorch came out in 2017, we spent over 1,000 hours testing it before deciding that we would use it for future courses, software development, and research. Since that time, PyTorch has become the world's fastest growing deep learning library and is already used for most research papers at top conferences. This is generally a leading indicator of usage in the industry because there are papers that end up getting used in products and services commercially. We have found that PyTorch is the most flexible and expressive library for deep learning. It does not trade off speed for simplicity, but provides both. So PyTorch works best as a low-level foundation library, providing the basic operations for higher-level functionality. The fastai library is the most popular library for adding this higher-level functionality on top of PyTorch. It's also particularly well-suited to the purposes of this book because it is unique in providing a deeply layered software architecture. There's even a peer-reviewed academic paper about this layered API. Yes. Yes. I think if you don't know what I'm talking about right now, you will know once you start doing PyTorch. Okay. So in this book, as we go deeper and deeper into the foundations of deep learning, we will also go deeper and deeper into the layers of fast AI. This book covers version 2 of the fastai library, which is a from-scratch rewrite providing many unique features. However, it doesn't really matter what software you learn because it only takes a few days to switch from one library to another. What really matters is learning from the deep learning foundations and techniques properly. Our focus will be on using code that, as clearly as possible, expresses the concepts that you will need to learn. Where we are teaching high-level concepts, we will also use high-level fastai code. Where we are teaching low-level concepts, we will be using low-level PyTorch or even pure Python code. Though it may seem like new deep learning libraries are appearing at a rapid pace nowadays, you need to be prepared for a much faster rate of change in the coming months and years. Very true. As more people enter the field, they will bring more skills and ideas and try more things. You should assume that whatever specific libraries and software you learn today will be obsolete in a year or two. Or we could just start off with obsolete software to begin with and know what we're getting into. Just think about the number of changes in libraries and technology stacks that occur all the time in the world of web programming, a much more mature and slow-growing area than deep learning. We strongly believe that the focus in learning needs to be on understanding and the underlying techniques and how to apply them in practice and how to quickly build expertise in new tools and techniques as they are released. Okay. So by the end of this book, you'll understand nearly all the code that's inside fastai. Well, that's exciting, and much of PyTorch too. Okay, because in each chapter, we'll be digging a level deeper to show you exactly what's going on as we build and train our models. This means that you'll have learned the most important best practices used in modern deep learning, not just how to use them, but how they really work and how they are implemented. If you want to use those approaches in another framework, you'll have the knowledge you need to do so if needed. Okay, so since the most important thing for deep learning is writing code and experimenting, it's important that you have a great platform for experimenting with code. The most popular programming experimentation platform is called Jupyter. This is what we will be using throughout this book. We will show you how you can use Jupyter to train and experiment with models and introspect every stage of the data preprocessing and model development pipeline. Jupyter is the most popular tool for doing data science in Python for a good reason. It is powerful, flexible, and easy to use. So we think you will love it. So let's see it in practice and train our first model. All right. Yeah. Sorry to leave this in the cliffhanger, but we'll continue next time.